Hello everyone, in this video I'm going to go over a few problems on Raoult's law. So I'll go over these problems. There are like 5 different problems over here. So let's start with the first one. It says we have 100 gram of liquid A and it dissolved in 1000 gram of liquid B, and they gave us the molar mass and they gave us the vapor pressure of pure liquid B, and we need to calculate vapor pressure of pure liquid A and its vapor pressure in the solution, and they gave us the total vapor pressure 475 torr. So let's write down some formulas from Raoult's law. So we know that PA, partial vapor pressure of A, is equal to P naught A, which is the vapor pressure of pure liquid, multiplied by its mole fraction, and similarly PB is equal to P naught B XB, and we also know that PT is equal to, the total pressure is going to be PA plus PB, and PA is P naught A XA plus P naught B XB. So whenever I solve a problem, I always write down what they have given us, like what is given in the problem, and then I write down what I need to calculate, and then I use the formula, like appropriate formula that will help me to solve the problem. So first of all, they gave us the vapor pressure of pure liquid B. So that means they gave us P naught B, and this is equal to 500 torr. And they also gave us total vapor pressure, which is PT, and it is equal to 475 torr. And they are asking us to calculate vapor pressure of pure liquid A. So P naught A we have to find. This is unknown. And it's a vapor pressure in the solution. So vapor pressure in the solution is PA. So we need to find PA. So we can definitely use this formula over here because we know P naught B. We need to find P naught A, and they gave us PT. And the other things, unknown things in this formula are XA and XB, the mole fractions of A and B. But they gave us the molar mass, so we can find the mole fraction easily. So let's see, let me write down the formula for mole fraction. So we know that mole fraction is, I'm gonna do the mole fraction on this side. So mole fraction is equal to number of moles of component. So number of moles of component divided by total number of moles of all components. So total number of moles of all components. So to calculate the mole fraction, we need to know the number of moles of each component. So our case it's A and B. Let me write down the formula how to find the number of moles of a component. Let's say Na, the number of moles of component A or our liquid A, and it is equal to the mass of this component, or we can say mass of solute, because our component A is in less quantity compared to component B. So this is our solute. So mass of solute divided by molar mass of the solute. Molar mass of solute. So Na is equal to, and mass of solute is 100 gram. So 100 gram divided by molar mass, which is 140 they gave us, and when we solve it, it comes around 5/7 mole. Similarly, we can calculate Nb. and it is going to be mass of the solvent, which is 1000 gram, and divided by molar mass of the solvent, and gave us it is 180 gram per mole. And when we do the calculation, this gives me 50 over 9 more. Now we can calculate mole fraction. So mole fraction, let's say for component A, XA is going to be number of moles of component A. So it is 5 over 7 divided by total number of moles of all component. So it's going to be 5 over 7 plus 50 over 9, and when we solve this mathematically, this gives me 0.114. Similarly, we can calculate xb, and there is another way to calculate xb, because we know for binary solution the sum of mole, not binary, in all solutions the sum of the mole fraction of all the component is going to be 1, and in our case we have a binary solution, so xa plus xb is equal to 1, and if we know 1 we can calculate the other, so xb is going to be 1 minus xa. So we know xa, so xb is going to be 1 minus xa, which is 0.114, and this gives me xb is going to be equal to 0.886. So now we know the mole fractions xa and xb. We can use this formula to find p naught a, because everything else we know in this formula now. Let me rewrite this formula over here. So we got PT, the total pressure, vapor pressure, is equal to P naught A XA plus P naught B XB. Now let's plug in all the values. So PT is 475 torr, that is given, is equal to P naught A, that's what we are trying to calculate or find, that's unknown, multiply by XA, which is 0.114, plus P naught B, they gave us that in the equation or in the problem, 500 torr, multiply by XB, which is here, we calculated it, 0.886, and 475 is equal to P naught A times 0.114, plus when we multiply these two numbers gives me 443, and subtracting 443 from both sides gives me 475 minus 443 is equal to P naught A times 0.114. Now we can divide both sides by 0.114, 0.114 divided by 0.114, and these will cancel out over here. So we're left with P naught A equal to, when we solve this here, gives me, so just subtracting and dividing by 0.114, this gives me 280.7 torr. So that's our first unknown. So second unknown, PA, we know PA is equal to P naught A times XA, and P naught A we just calculated is 280.7, multiply by the mole fraction XA, which is 0.114, and when we solve it or multiply it, this gives me 32 torr. So PA is equal to 32 torr. So P naught A 280 and PA 32 torr. So that's how we can solve this problem. We need to write down what is given, we need to find, and then use the formulas we know from the Raoult's law, plug in the values and find unknowns. Let's go over second problem. So second problem says vapor pressure of pure liquid A and B are 350 millimeter of mercury and 600 millimeter of mercury respectively at 300 Kelvin. Find out the composition of a liquid mixture if total vapor pressure. So they gave us the total vapor pressure and they are asking us to find the composition of liquid mixture, which is basically the mole fraction of the liquid mixture. And they're also asking us to find the composition of vapor phase. That is again the mole fraction of the component in the vapor phase. So let's solve this problem. Again, first of all, let's write down what they gave us. So they gave us the vapor pressure of pure liquids A and B. So that means P naught A, and it is equal to 350 millimeter of mercury. That's the pressure they use in barometer, like to measure atmospheric pressures as well, millimeter of mercury. And then we got P naught B is 600 mm of mercury. And the total vapor pressure, they also given that PT 500 mm of mercury. And now what we need to find the composition of the liquid phase. That means the mole fraction of liquid phase, the component A and component B. Similarly, the composition of vapor phase and the mole fraction in vapor phase we represented by Y. So YA and YB. Okay. So now we can use the formula or the equation from Raoult's law. We know PT is equal to P naught A XA plus P naught B XB, and we know that the sum of XA and XB is equal to 1. We can plug in the value of XA here or XB here, and we can rewrite this equation as PT equal to P naught B plus P naught A minus P naught B times XA. So this equation I just got it from I just plugged in value of XA over here. So XA is going to be 1 minus XB. Or I think it was maybe XB is equal to 1 minus X. You can try it and you can easily rewrite this equation in this format. So I wrote in this format because I know PT, I know P naught B, so I know P naught A and P naught B, and I can easily calculate XA. Once I calculated XA from this formula, I can calculate XB. Okay, let's plug in what they have given us. So PT is 500 mm, so 500, and P naught B is 600 plus P naught A is 350 minus P naught B is 600, and we don't know XA, that is unknown. Now subtract 600 from both sides, so this will gives me 500 minus 600 is equal to 350 minus 600 XA, because 600 here will cancel out this. So this gives me negative 100 is equal to negative 250 XA multiplied by negative 1. This will cancel out the plus sign, or we can say divide both sides by negative 100. And that will solve the problem again. This is the same thing. So this will give me 1, the negative sign will cancel out. This gives me XA is equal to 100 over 250. And when we do the math over here, this gives me 0.40. So XA is 0.40. And if I plug in this XA here, this gives me XB is equal to 1 minus 0.40. So XB is going to be 0.60. So now we know the mole fraction of XA and XB, which is basically the composition of liquid mixture. Now let's calculate the mole fraction in vapor phase. So we need to find the formula for that. So formula is the partial pressure of a component. So partial pressure of a component is equal to mole fraction of component in vapor phase. So mole fraction of component in vapor phase, component in vapor phase times total pressure in vapor phase, times total pressure in vapor phase. And we know partial pressure of a component. Let's say we are talking about component A. So partial pressure of component A is going to be equal to mole fraction of component in vapor phase. So in vapor phase, the mole fraction of component A is YA multiplied by total pressure in vapor phase, which is the total pressure over here, PT. So from here we can say YA is equal to PA divided by PT. And we know that PA is equal to P naught A XA divided by PT. So if we plug in the value of P naught A here, which is 350, so 350 multiplied by XA, which we calculated 0.40, and divided by PT, which is 500. And when we do the calculation, this gives me 140 over 500, and it's going to be equal to 0.28. So YA is equal to 0.28. So that's the mole fraction of component A in vapor phase. And we can calculate YB similarly. So YB is equal to PV divided by PT is equal to P naught B XB divided by PT, and it is going to be equal to P naught B is 600 and XB is 0.6, so we calculated it over here, 0.60 you can say, multiply by total 500, and when we solve it, YB comes out to be equal to 360 over 500 gives me 0.72. We can also use the formula YA plus YB equal to 1, and YB is going to be 1 minus YA, because we already calculated YA over here. That will give us the same answer. So now we know YA and we know YB. So that's the composition of vapor phase. That's another kind of problem you can practice. Let's go to next one. So this problem says a mixture of ethyl alcohol and propyl alcohol has a vapor pressure of 290 mm. So two mixture of ethyl and propyl. So total vapor pressure is 290 mm. The vapor pressure of propyl alcohol, which is the pure propyl alcohol pressure, vapor pressure, 200 mm. If the mole fraction, so X of ethyl is 0.55, what is the vapor pressure at same temperature? So we need to find the vapor pressure of ethyl alcohol, that means. So let's write down what they have given us. So mixture of ethyl and propyl and vapor pressure is 290. That means total pressure is 290 mm. Then they said the vapor pressure of propyl alcohol, so vapor pressure P naught propyl, because that's the vapor pressure of pure propyl alcohol, 200 mm. Because they didn't say partial vapor pressure, they just said vapor pressure. That means that is a vapor pressure of pure propyl. And then they gave us, if the mole fraction of ethyl, so that means X ethyl, so they gave us the mole fraction of ethyl alcohol 0.55. So we can find the the mole fraction of propyl. We can just subtract 1 minus the mole fraction of ethyl, which is 0.55, and this is going to be equal to 0.45. So we got the mole fraction of propyl. And what are they asking us to calculate? They are asking us what is the vapor pressure of ethyl alcohol. So they are asking us P naught ethyl. So we're going to use the same formula. P total is going to be equal to P naught propyl multiplied by X propyl plus P naught ethyl alcohol multiplied by the mole fraction of ethyl. Okay, so lot of values are already given, so we can plug in what they have given us. So PT, the total pressure they gave us already, which is 290 mm, 290, and P naught propyl is 200 multiplied by X propyl, which we just calculated, is 0.45, plus P naught ethyl is that's what we need to calculate. So P naught ethyl times mole fraction of ethyl alcohol is 0.55. So 290, and when we multiply them, this gives me 90 plus P naught ethyl times 0.55, and if I subtract 90 from both sides, if I subtract 90 here and minus 90 here, so this gives me 200, and this 90 will cancel out this, and this gives me P naught ethyl times 0.55, and if I divide both sides by 0.55, so these two will cancel out, and 200 over 0.55 is going to be 363.63. So P naught ethyl. So that means P naught ethyl, the vapor pressure of ethyl alcohol is going to be 363.63 mm. Do not forget the units. So as they given in mm, so it is going to be in mm. So this was a relatively easy problem, but you never know. So practice easy and then you can move forward towards more difficult problems. Now let's go to the next one. So it says for a binary liquid solution of A and B, the mole fraction of A in a liquid and vapor phase. So they gave us the mole fraction of A in liquid and vapor. So in a liquid, that means XA. So it is equal to 0.60, and in a vapor they said it is, and we represented a y, yb is equal to 0.35 at 400 torr. So 400 is basically the total pressure. So P total 400 torr, because it's a binary solution at 400 torr. So that's the total pressure. And they're asking us what are the vapor pressure of pure liquid A and B. So that means we need to find P naught A and P naught B. From the previous equation, problem, this one, we're gonna use this formula to calculate it, because they gave us the mole fraction of the component B in a vapor phase, and they are asking what are the vapor pressure of pure liquid A and B. They gave us YB, we can calculate YA and use the formula. So let me write it down. So YA, mole fraction of component A in a vapor phase, is going to be equal to PA over PT, and PA we know that is equal to P naught A XA over P total. And if we rearrange this formula, this will be, this can be, if we let's say multiply both sides by PT. So multiply by PT here. Gonna multiply PT here. So this will cancel out this PT, and we left with PT YA is equal to P naught A XA, and we want to calculate P naught A, so we're gonna divide both sides by XA and XA, and this XA will cancel out, and we left with P naught A is equal to YA times P total over XA, right? So P naught A is equal to PT YA divided by XA. And look at what is given to us. PT is given, YA, we can calculate YA from here because YB is 0.35, sorry, it is YA, not YB, because it says mole fraction of A in liquid and vapor phase. So mole fraction of A in liquid and mole fraction of A in vapor phase. So YA is given. So let's plug in the values. So P naught A is going to be, PT is 400 times YA 0.35 divided by XA, which is 0.60, and when we solve it, this gives me 233 torr. Like multiply and divide by 60. So P naught A is equal to 233. Similarly, we can write the formula for P naught B, but we can copy it from here, and this gives me P naught B is equal to PT, gonna stay same, multiply by mole fraction of component B in vapor phase by B divided by XB. Okay, now here PT, we know that PT is 400 what will be the value of YB? Because we know YA is 0.35, so YA plus YB is equal to 1. So YB is equal to 1 minus YA. So YB is equal to 1 minus 0.35. So YB is equal to be 0.65. So 0.65 divided by XB. Similarly, XA plus XB, I'm gonna write it down, equal to 1. That means XB is equal to 1 minus XA. So XB is equal to 1 minus XA is 0.60. So XB is equal to 0.40. So divided by 0.40, and when we solve it, P naught B is going to be equal to 650 torr, and that's what we were looking for, P naught A and P naught B. So P naught A is here and P naught B is here. So write down the formula and play around with it to check what is given and what is missing, and we can use the formula to solve our problem. Okay, so next problem, this is our last problem. So they gave us a mixture of two component, volatile component A and B has total vapor pressure. So they gave us the total vapor pressure equal to this formula, 254 minus 119 multiplied by mole fraction of B. And they are asking us to calculate P naught A and P naught B, which is basically vapor pressure of pure A and pure B. So let's write down what they gave us. They gave us P total is equal to 254 minus 119 XB, and we need to find out P naught A is missing and P naught B is missing, and we know that P total is equal to P naught A XA plus P naught B XB, and we also know XA plus XB is equal to 1. So we can say XA is equal to 1 minus XB. What we're gonna do over here, we're gonna plug in the value of this XA in this equation. So this will give me P naught A, and XA can be written as 1 minus XB plus P naught B XB. Let's open the parenthesis. P naught A multiplied by 1 gives me P naught A. P naught A multiplied by XB gives me P naught A times XB plus P naught B XB. And so this is going to be, in these two terms we have XB common, so we can take out XB as common. So P naught A minus, so P naught A plus P naught B, and we take out XB common. And they gave us P total is equal to this number or this equation, which is 254 minus 119 XB. Now if we look at these two equations, one on left hand side and other on right hand side, and compare the terms, so first term 254 is basically equal to P naught A, and then we got minus sign and minus sign, then we got XB and XB. So that means this P naught A plus P naught B is basically equal to 119. So we can write P naught A is going to be equal to 254, and P naught A plus P naught B is going to be equal to 119 because they are the like terms. And we already know P naught A is 254, and if we plug it over here, 254 plus P naught B equal to 119. I made a mistake over here. Let me see. So when I take out this negative sign here, this is not supposed to be positive. So it's supposed to be a negative sign over here. Sorry about that, guys. It happens sometimes. So this is supposed to be negative sign. That's why when negative multiply negative gives me positive. So this is not going to be positive. It's going to be a negative sign here. And same thing here, going to be negative. So now let's subtract, if we subtract 254 on both sides, so 254, right, minus 254. So this is a negative 254, this is positive, will cancel out, and we're left with a negative P naught B is equal to negative, and if we subtract 254 from 119 gives me 135, multiply by negative 1 on both sides gives me P naught B equal to 135, and we have P naught A over here. So we found both the unknowns, P naught A and P naught B. That was a different kind of problem, but there are many different kinds of problem, but they are easy to solve once you know the formulas and once you know how to use those formulas. Always write down what is given and what is missing, and then write down the formula to see what makes sense, like what terms are already given, and you can use the formula to solve your problem. So these were a few problems on a Raoult's law. Please do practice more problems and you guys will be good to go. And also please do share, subscribe my channel and like my videos because this motivates me to make more videos. Thank you. Have a good day, guys. Bye-bye.